So for 11 through 14, we're now dealing with our isosceles triangle and the isosceles triangle theorems. So for number 11, it tells me triangle CDE is congruent to triangle HIJ. CE equals 5x and HJ is 2x plus 15. Find x and CE. So what I'm going to do is I'm going to come back to my congruence statement because I know that in my congruence statement, I don't need to draw a picture of my triangle because my vertices are already lined up. I know based solely on my congruence statement and the fact that C was first and E was last, and H was first and J is last, that CE, I can conclude CE is congruent to HJ. And of course, because of the definition of congruence, I know CE equals HJ. So what we're going to do is we're going to substitute the numbers in and solve for x. So 5x is for CE. HJ is 2x plus 15. Now we're just going to simply solve for x. So we're going to subtract 2x from both sides. I get 3x equals 15. Divide both sides by 3. So x equals 5. Now I've done half the question because it said find x and find CE. Well, CE is easy because we know CE is 5x. And if I were to substitute what I just found x to be, CE is 25. Oops, sorry guys. Number 12. What is the length of the longest side? Now many of you today said, Coach, this is an isosceles triangle, so my base is the longest side. We cannot assume that. But Coach, it looks longer. Well, you may be correct. It may appear to be longer, but in geometry, I cannot assume length based off of what I see. I have got to prove it. So they've given me this isosceles triangle with an x on all three sides, and they said, what is the length of the longest side? In order to do this, we have got to find the value of x. And to do that, we're going to exploit our isosceles triangle relationship because it's an isosceles triangle. And it shows me, based on these two tick marks, that this triangle is an isosceles. I can assume, because they told me, that 4x plus 2, or minus 2, equals 3x plus 6. They are congruent, which means they are equal. So we're going to add 2 to both sides. And on the same step, don't hurt me, I'm going to subtract 3 from both sides. So now I've got x equals 8. Well, that's great, but it doesn't show me the longest side. In order to do that, I need to plug it in. And then you guys are going to see, hopefully, E is 24 plus 6. Now, if I've done my math correctly, when I plug 8 in for x on this left side, it should also equal 30. Let's cross our fingers and hope that's what happens. So 4 times 8 minus 2 is 32. Minus 2 is 30. Well, hallelujah. Okay, so we're good. We've proven our isosceles triangle. We got the math that backs us up. So one of those two could be our longest side. Let's see what happens. So I plug in 8 again. So 5 times 8 minus 3 equals 40 minus 3, which is 37. So my longest side is this joker right up top. That's going to be my longest side because the math says so. Not because that's what it looks like, but because the math says so. 13. What is the measure of the vertex angle? So if we think back to what we learned on Tuesday, and I've got my isosceles triangle. It doesn't look very isosceles, but I told you. So this joker up top, that's not congruent. That's my vertex angle. And these two guys on the bottom are base angles. They are congruent to one another. So it tells me that one of my base angles is 45. Well, thank you so much, math problem, because if you're telling me that one base angle is 45 and we're a bunch of smart cookies, we can conclude that my other base angle is 45 because it's an isosceles triangle. Now I'm just trying to find this little theta fella up here. So we're going to use our triangle sum theorem, and we're going to say that 45 plus 45 plus theta, remember that's just a variable for an angle, equals 180. So I get 90 plus theta is 180. We're going to subtract 90 from both sides. So theta, our vertex angle, is 90. Look at there. It was a right triangle and you didn't even know it. Number 14. An isosceles triangle that has a vertex of 3x and a base angle of x. So again, I've got my isosceles. Maybe I'll actually draw one that looks like one this time. That's a little better. I've got my isosceles, two congruent sides. The top, my vertex, is 3x, and my base angle is x. Well, they only told me one base angle, but we are smart. We remember, well, shoot, if they told me one base angle, they've definitely told me both of them. And again, we're going triangle sum theorem. So 3x plus x equals 180. So I've got 5x's equals 180. We want to divide both sides by 5. Pretty sure it's 36, but let me double check in the calculadora. So we divide both sides by 5, so we know x equals 36. So my base angles, because it wants us to know the value, are 36. And my vertex angle is 3 times 36, which is 108.